Today we are going to learn the very important concept about sets, that is the graphical representation of sets and its operations, which is very familiarized as Venn diagrams. What is set? Set is a collection of well-defined objects. Set can be represented in two ways. Already you learned. One is a roster form, other one is a set builder form. We can represent the set of elements in these two forms. But if you want to represent the same information in terms of graph or graphical representation or in diagrammatic form, that kind of representation can be done by using Venn diagrams. Then what is Venn diagram? A diagram or figure that represents the mathematical logic or relation between a finite collection of different sets is called Venn diagram. It is used to illustrate the set relationships. We usually use a circle or oval to represent a Venn diagram. It may have more than one circle. Each represent a set. So Venn diagram is a diagram which represents the relation between sets and its operations. Generally, the Venn diagrams can be represented by using circles. We call it as these Venn diagrams. Actually, that is Venn-Euler diagram. Simply, we call it as Venn diagram. Venn diagram consists of rectangles, closed curves, usually circles. Generally, we use the circles, rectangles, oval shapes, and triangles also. But actual notation and usual concept is the Venn diagrams can be used by circles only. The universal set is represented by, in general, a rectangle. Other sets are represented by circles. Just see this Venn diagram. There are three sets A, B, and C. Okay, B and C are lies in A. If A, B, C are represented three sets, means there is a relation between these three sets. B and C are the subset to the set A. C is a subset to set B. B and C are subset to set A. What is subset? If all the elements of one set are present in the other set, the first set is a subset to the. Let's take a small example. If you take A is set of triangles, B is set of acute angle triangles, C is set of equilateral triangles. As you know that every equilateral triangle is an acute angle triangle. The vice versa is not correct. Because what is an acute angle triangle? If each angle of a triangle is less than 90 or acute, then you call it as an acute angle triangle. In equal triangle, each angle is 60, means each angle is an acute. So basically, equilateral triangle is an acute angle triangle, correct? So C is a subset to B. And it is in a triangle. So B and C are subset to set A. Like a Venn diagram can represent the relation between the sets. So you can represent, or you can give an example to explain the advantage of these Venn diagrams. Let A is set A is set of 1, 2, 3, 4, 5, and B is set of 4, 5, 6, 7. Then find A minus B. This is the question. And by using the Venn diagram. So A minus B is a set which gives the difference of the two sets A and B, correct? What is A minus B here? The set of elements belongs to A but not to B. If you observe both the sets A and B, so there are some common elements 4 and 5. We can see the present of 4 and 5 in both A and B, correct? 1, 2, 3 are present in A only, and 6 and 7 are present in B only. If you see this Venn diagram, the set A is represented one circle and set B is represented by another circle. Both have common elements, hence the two circles represent intersecting circles which have the common area. So 4 and 5 lies on the common region. 1, 2, 3 belongs to A only and 6 and 7 belongs to B only. From this Venn diagram, you can write all the operations and other things also. You can write set A as 1, 2, 3, 4, 5, set B as 4, 5, 6, 7, A intersection B as set of 4 and 5, A minus B set of 1, 2, 3, B minus A set of 6, 7, A union B is 1, 2, 3, 4, 5, 6, and 7. See, from this Venn diagram, you can write all the relations of A and B. Clear? Okay. Just now I said the advantage of Venn diagrams. We will take one more example to get more clarity about the Venn diagrams. Take two sets M and N. The set M represents set of natural numbers between 10 and 40, each divisible by 3. Take N is another set of natural numbers up to 40, each divisible by 4. Draw the Venn diagram showing the relationship between these two. Now just observe it here. The Venn diagram represents the relation between these two sets M and N. So both have common elements 12, 24 and 36. 12, 24, 36 are both divisible by 3 and divisible by 4. 15, 18, 21, 27, 30, 33, 39 are divisible by only 3. 4, 8, 16, 20, 28, 32, 40 is divisible by 4 only. Hence, we can represent the relation between M and N by using this, correct? So, M minus N is set of 15, 18, 21, 27, 30, 33, 39. N minus M is set of 4, 8, 16, 20, 28, 32 and 40. M intersection N is 12, 24, 36. And M union N is all the elements. Like you can represent the relation between these two. Now, observe one more Venn diagram. The two sets, for example, these two sets represent the elements like set of 1, 2, 3, set of 8, 5, 9. Set A is set of 1, 2, 3, B is set of 8, 5, 9. So if you observe this, are you find any kind of common elements between these two sets? There is no common elements. For that reason, these two represented by two circles which are non-overlapping circles, non-intersecting circles. Clear? So later you can understand these two are disjoint sets. What is a disjoint sets? So the sets which have no common elements, we call it as disjoint sets, correct? Okay. Now we will just recapitulate the advantages and uses of Venn diagram just now what we discussed. The advantage of Venn diagram is it is used for both comparison and classification. It groups the information into different parts. It also highlights the similarities and differences. Clear? In the previous one, see, we can see the relation between A and B. Both are disjoint sets. Okay, in the previous example, we observed different parts of the sets also. First one is say M minus N. This is the M minus N. As you know, this is the M minus N area. And this is N minus M area. And this one will be M union N area. Like we can say the various parts of the Venn diagram also. What is each part represented by what? That's a very okay. Now, how to draw the Venn diagram? This is the most important. First, very important. And you have to write the union symbol either left or right top of the corner of rectangle. And generally, for representation of universal set, we will use the rectangle, and other sets we will use as circles. If the elements are the elements of, of course numbers are elements are in the set, then we can see inside the circles. If they are not belongs to that set, outside the circle, just we will see an example by you how we are going to explain this all these things. Okay, see this is the Venn diagram. Here T and G are two sets. Draw a set, two sets which are intersecting because they both have a common elements, two intersecting circles, and the whole will be draw universal set. And here 60, 80, 40, so concern to the sets, so they lies inside and 20 is lies outside. In this manner, we can draw the Venn diagram. I will explain this concept by giving an example also. Okay. So the Venn diagrams, this is a very useful thing to not only to represent the relations between the sets, but you can define various operations also. There are different kinds of Venn diagrams. I will list out this. One is two diagrams, two set Euler diagrams, three set diagrams, three set Euler diagrams, four set diagrams. In our syllabus, we have two set diagrams, so we have to discuss those things now. Two set diagrams. When two sets overlap each other is called two set diagrams. Here, just observe it here. One set is set A is set of AEIOU, means set of vowels in the alphabet, and another one is set of A, B, C, D, E, F, G. So in both the sets, so just observe the Venn diagram of subsets. So if a set A is set of all triangles, B is set of equivalent triangle. Just now observe one example, word problem it is. In an office, 200 employees are randomly selected for a survey. Out of what is the number of employees like only tea? Number of employees likes only green tea. What the number of employees like neither tea nor green tea? What the number of employees? Draw the Venn diagram first. Clear? Okay. So now we will see the solution here. We can represent the given information by the following Venn diagram, where T denotes the tea and G denotes the green tea. So the number of who likes only tea is 60, as you know it. Number of employees who likes only green tea is 40. The number of employees who likes neither tea nor green tea is 20. The number of employees who likes only one of the tea or green tea is 60 plus 40, which is 100. Clear? So number of employees who like at least one of the tea or green tea is simply you can have G plus N of T intersection G, that is 680. Clear? So this one we can represent. So 60 who likes tea, who likes green tea,